All right, we're about to go on a journey you take literally thousands of times a day and probably never think twice about. We are going to follow a single breath from the air all around you to its final, critical destination, deep inside your body's engine.
You know that feeling, right? Right before a big lift, or at the starting line of a race, maybe even before a tough conversation. You take that one single deep breath to kind of center yourself. But have you ever stopped to think about what's actually happening inside your body when you do that? Well, that simple action kicks off one of the most incredible delivery systems you can possibly imagine.
So let's do it. Let's follow one single molecule of oxygen. We're going to track it from start to finish. And I promise you, by the end of this, you will never think about a simple breath the same way again.
Okay, so our journey begins right here, at the port of entry, your lungs. The air has been inhaled, our little oxygen molecule has just arrived. This is where the real adventure starts.
Now, the technical term for this whole process is pulmonary ventilation. It sounds super complex, I know, but don't let the fancy name fool you. It's really just the scientific way of saying breathing, the simple physical act of moving air from the outside world into your lungs.
And here's how that magic happens. As you breathe in, your diaphragm contracts and your chest expands. This creates a vacuum that literally pulls air inside. Then, when you breathe out, those muscles just relax, and the air gets pushed back out. It's this simple, powerful, mechanical process that kicks this entire journey into gear.
Okay, so our oxygen molecule is now inside the lungs. But here's the thing. It's not truly in the body yet. It's kind of just visiting. To continue its journey, it has to make a huge leap across this microscopic barrier and merge onto the body's superhighway, the bloodstream.
This incredible leap is called pulmonary diffusion, and it is the most critical moment of exchange. See, your lungs are filled with millions of these tiny air sacs called alveoli, and each one is wrapped in a tiny blood vessel. This is the transfer point. This is where oxygen jumps from the air into your blood.
So how does it make that jump? It's all about pressure. Think of it like a really crowded room connecting to an empty one. The lungs are packed with oxygen. That's high pressure. The blood that's just arriving from the body is pretty much empty of oxygen. That's low pressure. And nature absolutely hates a vacuum, so oxygen just rushes from the high-pressure area to the low-pressure area, effortlessly dissolving into the blood. No extra energy required.
And what's just so amazing is that this is a two-way street. While all that oxygen is jumping in, the waste product, carbon dioxide, is jumping out of the blood to be exhaled. It is an incredibly efficient little exchange system. So our oxygen molecule has successfully made it into the bloodstream. It's on the highway, but it can't just float around on its own. It needs a ride, and that ride is one of the most important in the entire body. And this is where the heart comes in. The heart is the massive, powerful engine that drives this whole network. As soon as the blood is loaded up with fresh oxygen, the heart gives it this huge push, sending it racing to every single corner of your body.
So let's break down the key players here. Our oxygen molecule hitches a ride on a specialized taxi service called hemoglobin, which you'll find inside your red blood cells. And the speed of that taxi? Well, that's determined by your cardiac output, which is basically just how fast your heart is beating multiplied by how much blood it's pumping with every single beat. And this right here is exactly why your heart starts pounding when you work out. Your body is literally screaming at the engine to speed things up. By jacking up your heart rate and the amount of blood pumped per beat, your system dramatically accelerates oxygen delivery to the muscles that are desperately calling for it.
So after a high-speed trip through that circulatory system, our little oxygen molecule has finally arrived. It's at its final destination, the working muscles that power your every single move.
So how does it get off the superhighway and into the muscle? Well, it's the exact same way it got on, that pressure gradient again. The blood arriving at a working muscle is packed with oxygen. The muscle itself, because its burning fuel, is low on oxygen. So once again, our molecule makes the leap from high concentration to low, this time jumping directly into the muscle cell.
And this is it, the whole point of the trip, the final destination. Inside that muscle, our oxygen molecule is escorted to the cellular power plants, the mitochondria, where it is used to create something called ATP. And ATP, well, that's the energy currency that fuels everything you do, from lifting a heavy weight to just blinking your eyes.
So, we've followed this incredible journey, from a simple breath all the way to cellular energy. But why does understanding all this actually matter? Because, and this is the cool part, Every single step of this journey can be made more efficient. You can upgrade it.
Research shows there are a few key upgrades for your system. First, strong aerobic fitness makes your heart a much more powerful and efficient pump. Second, you can actually build more capillaries. Think of these as more off-ramps from the bloodstream superhighway that lead directly into your muscles. And finally, you can increase enzyme activity, which makes your muscles way better at actually using the oxygen once it finally arrives.
So the bottom line is this: a more efficient oxygen journey directly translates to real-world benefits. We're talking better performance, greater endurance, improved overall health. You can run faster, lift longer, and just feel better. Every single step we just walked through can be trained and improved. And that leaves us with one final thought. We've mapped out the entire incredible path of a single breath. We've seen unbelievable machinery at work behind the scenes. So the only question left to ask is, what are you going to do to make that journey even better?